All right, so let's pick up with number 13. And you can see that now we have a phase shift with this problem. So I'm going to show you how we take care of that. So let's first get the cosine by itself first. So we can do that by subtracting 3. So that would give us 3 cosine 2x plus pi over 2 is equal to negative 3. And then we divide both sides by 3. So you get cosine 2x plus pi over 2 is equal to negative 1. So like we did with the other problems, what we want to do is first figure out, well, where is cosine x equal to negative 1? We want to do that first. So going into the unit circle, if you want to have cosine x equal to negative 1, well, cosine is your x value. So thinking about the ordered pairs on the axis here, it's going to be at pi is negative 1 comma 0. That's your x value. So that's where cosine of x is equal to negative 1. So that happens at x equals pi. Well, that is just for cosine of x equal to negative 1. We have to deal with this phase shift here. So I'm going to go ahead and take that phase shift and set that equal. So I got 2x plus pi over 2 is equal to pi. And I'm going to go ahead and solve that. So I'm going to subtract pi over 2. And I get 2x is equal to pi over 2. And then you could divide by 2, which is easy to multiply by the reciprocal. And then when I do that, I get x is equal to pi over 4. So this right here gives me the answer within one cycle of whatever this period is. Well, what is the actual period? So here, go back, the period for cosine is 2 pi over b, and that's going to be equal to 2 pi over 2, which is equal to pi. So all we need to do then is add pi to this answer here, and then that will give us all of the solutions that we need. So we got the pi over 4, which is within 0 to 2 pi. Then if I add the period to that, that gives me 5 pi over 4. So here, this gives me my first answer because this value is within 0 to 2 pi. Then I added the period, and that gave me 5 pi over 4. So x total, all of the solutions for this within 0 to pi would be pi over 4 and 5 pi over 4. So if we only had one solution here, like let's say pi over 4, and then if we added the period and that went outside of this range, then it would just be this solution. Well, let's say you solve this and this is not even in this range here, well then you're going to have to either add or subtract the period to get within this range. So these would be the two answers for number 13. So let's go ahead and look at another problem. I'm just going to flip the paper here so I have enough room. So this is number 14. So we want to solve. So negative 2 plus 1/5 tan 2x plus 5 pi over 6 is equal to negative 2, and we're going to do the interval from 0 to 2 pi. So now I know the period for tangent in general is pi. We're going from 0 to 2 pi, so whatever we do, in the end, we have to make sure we get any solution that's within this interval right here. So let's start off by getting tangent by itself. So we're going to add 2 to both sides, and that's going to give me 1/5 tan, so 2x plus 5 pi over 6 is equal to 0. Then I'm going to multiply both sides by 5, which is going to give me tan 2x plus 5 pi over 6 is equal to 0. 0 times 5 is still 0. So now I have tangent by itself. Again, I got a phase shift. So we want to figure out when is tangent, I'll do it over here, when is tan x equal to 0? Let's figure that part out first. So go to your ordered pair coordinate plane right here, and you think about on the axes here. In order to get tangent to be 0, you need the y value to be 0. Well, that's going to be here at 1, 0 and negative 1, 0. So that happens at 0 and pi. Now I know that if you went all the way around, this would be 2 pi, but we're already within 0 to pi. We're not including that value, so this is enough. So now we're going to correct with this phase shift. So we're going to take each of these answers and we're going to have the 2x plus 5 pi over 6 equal both of those. So I'm going to do one over here. So 2x plus 5 pi over 6 is equal to 0. And then 2x plus 5 pi over 6 is equal to pi. So we're going to solve that. So I'm going to go ahead and subtract 5 pi over 6. So I get 2x is equal to negative 5 pi over 6. I'm going to multiply both sides by a half. So I get x is equal to negative 5 pi over 12. Now if you notice, this is outside of this range, and that's okay. We'll take care of it when we go through the rest of the problem. So here I'm going to subtract 5 pi over 6. So that gives me 2x is equal to pi over 6, multiply by a half, and that gives me x is equal to pi over 12. So I have these two solutions. Now this is inside here. Well, let's figure out what the period is, because the only way we're going to get the rest of the solution is to add the solutions, or to add the period to this. So the period for this problem right here, remember tangent is pi over b, so that's going to be pi over 2. So the period for this problem is pi over 2. Well, if you look at this answer right here, if I were to add pi over 2 to negative 5 pi over 12, I wind up getting pi over 12 right here. So adding it to this one would already give me this. So I only need to start here at the pi over 12 and then just keep adding the answers. So I got pi over 12, that's one of them. Then I'm going to do pi over 12 plus the period, so which is pi over 2, and that gives me 7 pi over 12. That's still within the range. Well, let's do it again. So now I'm going to do 7 pi over 12, so I have this answer here. Then I got another answer. Let's add pi over 2 and see if we're still in the range. And when I add these two together, 7 pi over 12 plus pi over 2, that's going to be 13 pi over 12. That's still within the range of 0 to 2 pi. So if I do it again, I'm going to add pi over 2, and that's going to give me 19 pi over 12. And that's going to be it, because if I add another pi over 2, I'm going to be outside of this range. So all 4 of these are going to be the answers for this problem right here. So pi over 12, 7 pi over 12, 13 pi over 12, and 19 pi over 12. Let's see if I can get another one in here before I hit that 15-minute mark of the video. So I'm going to flip the page, and let's look at, line this up here, number 15. So we're going to solve negative 3 minus sine negative 4x plus pi over 6 is equal to negative 4, and we're going to go in the interval of 0 to 2 pi. Now, this is the first time that you're going to see a negative in the front here. You're not used to that. We could fix it using an even odd relationship, but it's not necessary. We can still do the problem the way we've done it in number 14, and it'll still work out, as you'll see. So let's get the sign by itself. So I'm going to go ahead and add 3 to both sides. And that's going to be negative sine minus 4x plus pi over 6 is equal to negative 1. and then I'm going to divide by -1. So I get sine of -4x plus pi over 6 is equal to 1, because we're dividing. So again, what we want to do is let's figure out when is sine x equal to 1. So if you go to your coordinate plane, it's going to be on the axes, and we want the y value to be 1, and that's going to happen here at pi over 2, which is 90 degrees. So I only get one answer for here, so all I have to do is set that up, take the inside here, which will wind up being our phase shift. So you get -4x plus pi over 6 is equal to pi over 2. And then we're going to subtract pi over 6. So you get -4x is equal to pi over 3. And then we're going to divide by -4, which is the same as multiplying by -1/4. And you get x is equal to -pi over 12. So now that is outside of this range of 0 to 2 pi. So let's get the period of this right here, and then we can use that to get inside this range. So the period for tangent is pi over b. Now technically it's pi over the absolute value of b. That's how we can work with this problem with the negative. So this is going to be pi, oh, I'm sorry, it's 2 pi. Sine is 2 pi over b with absolute value, so it's 2 pi over 4, and that's going to equal pi over 2. And now from there, we can go ahead and keep adding pi over 2, which is the period for this specific function. We can keep adding that so we get into this range. So if I add pi over 2 to -pi over 12, that gives me 5 pi over 12. So that's within this range. Well, let's keep doing that. So there's one value right there. So I'm going to do 5 pi over 12 plus pi over 2 again. That's going to give me 11 pi over 12. So I'm still within this range, and I can still add some more. So I'm going to add another pi over 2. That's going to give me 17 pi over 12. That is still within this range, and I actually can do it again, because if I add pi over 2 one more time, that gives me 23 pi over 12, which is still within the range of 0 to 2 pi. So I have those 4 solutions for this problem right here: 5 pi over 12, 11 pi over 12, 17 pi over 12, and 23 pi over 12. All right, so the next problems that we're going to do, we have to break it up into the next part. They're going to involve using some trig identities, so it'd be better to break that up into a separate part anyway. All right, see you next time.